Okay, now, that is everything that is longer than visible light. So visible, infrared, microwave, radio. Let's go shorter than visible light. Okay, so the next category of visible light is just going to be a little bit shorter than visible light. Okay, and this particular one is anything between about 10 nanometers to that 400 nanometers where visible light comes in. So 10 to 400 nanometers. So let's figure out what this is. Okay, if radio light, based on what we just said about radio, this light is a little bit shorter wavelength than visible. So what can we say about its frequency and energy compared to visible light? If this stuff is a little bit shorter than visible, what can you tell me about its energy and frequency compared to visible light? It looks like somebody already said the name, but what can you tell me about the energy? It's higher, right? This is higher energy and higher frequency than visible light, and specifically, it's just a little bit higher than violet visible light, because that's the highest energy visible light, and that's where this stuff gets its name, as one of you guys pointed out. It's called ultraviolet. Ultraviolet. And that's usually abbreviated to UV. UV light and ultraviolet light are the exact same thing. Yeah, because this is a little bit higher energy than visible light, it's just high enough energy to be really dangerous for us, okay? This is high enough energy to hurt us even in small amounts. Visible light can hurt us, but you would need a lot of it to hurt us, right? Ultraviolet can hurt us even in small amounts because of its high energy, okay? In fact, when I was a little kid, I thought everybody was calling it ultraviolet light, but, I mean, that's it basically works, because everybody's like, oh, watch out for ultraviolet light, but what can you do? It's ultraviolet, okay? Now, why is it dangerous? Well, let me ask you this. What part of the human body do we usually worry about being damaged by ultraviolet light? What part of us is most susceptible to this? Skin's one of them. Skin's probably the one that we're most... there's the other one, eyes. Skin and eyes. Those are the main things we think of as being damaged by ultraviolet light. What do those two things have in common? What do they have in common? They're both on the outer part, right? Your skin and your eye. Basically, any part of your body that is exposed can be damaged by UV light, right? Now, how does that work? Here's a sort of crude simplification, okay? I'm going to show you basically how this works. Let's imagine that you zoomed in really close on your skin or your eyes. They're made of cells, right? So imagine that this is like the surface of your skin. It's like a bunch of skin cells. Okay, so there we go. There's your skin. Let's say some visible light came in. Okay, let's say some visible light came in. I'll label that with a V for visible light. Now, when that visible light gets to your skin, it doesn't have a lot of energy. So what it's likely to do is it's likely to reflect, just bounce off. And a little bit of it might get absorbed, but for the most part, just to simplify this, we can imagine it's just bouncing off. Okay, so visible light comes in, visible light goes out. Okay, not a lot of energy. On the other hand, UV light has a much shorter wavelength. So here, let me get some shorter wavelength UV light coming in. And because it has a shorter wavelength, we said it has a higher energy, and it has enough energy to puncture your skin. Okay, the photons of UV are able to come in and just shoot a hole through that skin. It's not going to go all the way through your body because it loses energy as it punches through, but it's able to punch through like a little bullet. Okay. So somebody's asking about size. Is it the size? It's hard to talk about the size of light because they're all, these microscopic photon particles. They're so small that you get really weird effects that come in at that size. So let's not really think about size so much. It's really just the energy that's important here. Good question, though. Very good question. Now, check this out. So like I said, the UV light's coming through. It's basically like a bullet. This is like somebody threw a baseball at you. It might hurt a little bit, but it's just going to bounce off of you. This is like somebody shooting you with a gun, right? So this is a bullet coming through. If somebody shoots you with a bullet, what might happen to you? What might happen to you? You're going to definitely get really damaged, but what might happen? Sorry for the metaphor. Yeah, you might die, right? You might be able to survive, but you might die, right? And so guess what happens to your skin cells if the UV light shoots through it like a bullet? What happens to them? What could happen to these skin cells if a bullet-like UV light goes through them? What might happen in that case? While you guys are answering that, I gotta restart the program. They might die also. That's right. So, they might die. So when the UV light hits your skin cells, UV light kills skin cells. They might be able to repair themselves, but they're likely to die, right? So UV light literally kills skin, okay? And if somebody pointed this out, if enough of these skin cells die, we call that a sunburn, okay? So a sunburn is a bunch of dead like just a bunch of dead skin cells in your body. And one way you can tell that they've been killed is that frequently after a bad sunburn, if you come back after a few days, what's going to be going on? If you had a sunburn like a week ago, what happens to your skin like a week later? Yeah, it starts to peel. That's dead skin falling off, right? That's dead skin falling off. It's basically the UV was able to penetrate and kill your skin kind of deep in there, and that skin slowly worked its way to the surface and fell off all dead. Yay! UV. And your eyes are a little bit more protected, but they can also get cells killed by UV also. And that's kind of unfortunate because what gives off UV? What gives off UV light? What's some sources of UV light we need to worry about? Yeah, the sun's the big one. Every time you go out in the sun, UV light is killing small parts of you. It's killing small parts of you, right? That's not the only thing giving off a lot of UV light. Lightning does give off some UV, but something that you're going to have to deal with every day. Most computer screens and cell phone screens and TV screens also give off a pretty high amount of UV light. And what part of your body is in danger here? Your eyes, right? So every time you stare at a cell phone, you're just exposing your eyes to death rays all the time. So there you go. Now, by the way, my glasses have a UV protective layer to help block UV from coming into my eyes. So maybe you might want to think about that, okay?